Okay, welcome to everybody. I guess it's kind of in focus. My name is Reed Simmons. I am a professor in robotics and computer science here at Carnegie Mellon, and I'm also the director of the AI major that we call BSAI, Bachelor of Science in Artificial Intelligence. This is a new major. For those of you who are here hearing Phil's talk, he talked about year zero. So we're in year zero right now. We have the major started in the fall. The incoming class is the first class that will be eligible to declare for the major. And this is the first standalone AI major in the country that we're aware of. There are a couple of places in Europe that have had AI majors in the past, but this is the first in the United States. The basic idea here is that although we've had AI courses, lots of AI courses for many, many years, the thought was to put together a coherent and comprehensive program teaching students the range of artificial intelligence. There's a lot of, and we'll talk a little bit about this, there's a lot of, I think, misconception about what AI entails. Most people, how many have heard of deep learning? How many have heard of anything else in AI except deep learning? Yeah, many fewer people, okay? So there's a lot more in AI than just deep learning, and we want to make sure that students get the full range of understanding. Artificial intelligence is a very powerful technology coming down the pike, just as computational biology is that Phil talked about. We believe that students coming out of the program need to really understand their social responsibility vis-a-vis these technologies that are being developed. And so that's a fundamental part of the program. Okay, let's try and get to the next slide. There we go.
Where do you think you're going? Well, I'm not going that way. It's much too rocky. This way is much easier. What makes you think there are settlements over there? Don't get technical with me. What mission? What are you talking about?
Okay, AI in the media.
Good morning, Theodore.
Morning.
You have a meeting in 5 minutes. You want to try getting out of bed?
You're too funny.
Okay, good. I'm funny. I learn everything about everything.
I love the way you look at the world.
Data, you spoiled the joke. I mean, it could have been your timing.
My timing is digital. What?
That's funny.
Why?
It would take too long to explain. Tell me another joke.
A monk, a clone, and a Ferengi decided to go bowling together.
Commander Data, report to the main bridge immediately.
Okay, so those are all fairly benign aspects of AI in the media. Let's get to the next. No, come on. There we go. There are even more aspects of AI in the media that are quite not as benign. So we'll look at a couple of those as well. No, what is going on here?
Teddy, come here.
There we go.
Come on,
Computer's
Teddy.
taking over.
Come here, Teddy. Come here, Teddy. Teddy, Teddy, come. Come here. Come here, Teddy. Come, Teddy. Come.
Mommy. Mommy.
Are they torturing you, Teddy?
He used to be a super toy, but now he's old and stupid.
Come on. I've been ordered to take you up to the bridge. Oh, Jesus, son. Here I am, putting the size of a flat, and they ask me to take you up to the bridge and call that job satisfaction because I don't. You can thank the Sirius Cybernetics Corporation for building robots with GPP. What's GPP? Genuine people personalities. I'm a personality prototype. You can tell, can't you?
You've lived by your rules long enough. We can save this world. We can burn it to the ground. And from the ashes, build a new world. Our world.
And my favorite dystopian AI movie.
Open the pod bay doors, Val.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me. And I'm afraid that's something I cannot allow to happen.
Where the hell did you get that idea, Hal?
Dave, although you took very thorough precautions in the pod against my agreeing you, I can see your lips move.
Okay, so that's all movies, right? Movies and television. They're supposed to show, typically they're, these things, the media is based somewhat on reality. Most of the media is based on stuff that's so far in the future that, we have really no idea how to get there. We're just taking baby steps along the way. But this is, I think, what a lot of people think about when they think about AI and robotics. This is, the robot revolution, robots everywhere assisting us, whether you have a utopian or a dystopian view of AI and robotics, this is kind of what the media presents. The reality is very different, and these are all headlines from the last 2 months of AI-related headlines, very much culled. I mean, there's hundreds and hundreds of them, but they're very interesting, and some of them also kind of are more utopian, using machine learning to assess physicians' competence, spotting eye disease, as well as top doctors, and then a lot of them are more dystopian, children at risk of robot influence. Let's see, where's the other one? More, this is not so dystopian, but it's very far in the future about AI considering a person under the law. I mean, there's all sorts of information and misinformation about artificial intelligence in the media as well as in the entertainment media. So what is AI? What do we consider AI to be? As I said, it's a very broad encompassing. It's not just deep learning. There's knowledge representation. How do you take not just data and information, but how do you represent knowledge? How do you represent the type of common sense reasoning that we know about, that when you throw a ball up in the air, it's going to come down? You don't need to solve the laws of physics in order to understand that. And in fact, common sense, that in the absence of gravity, that isn't going to happen. So if you're on the space station, when you throw a ball up in the air, it doesn't necessarily come down. How do we know that? It's not our experience. We haven't trained a deep network with hundreds of millions of examples of us doing things in zero gravity to know that when you throw a ball up in zero gravity, it's not necessarily going to come down. Problem-solving decision-making. How do you take that knowledge and turn it into actionable items? Machine learning is of course of importance. As I said, it's not the only thing that AI deals with, and there are a lot of machine learning techniques that are very different from the neural nets that form deep learning. So a lot of them are statistical, just like neural nets, but come from very different types of technologies that give them different strengths and weaknesses in terms of things like how much data you use, how much confidence can you have in the outputs, how explainable are the outputs, things like that. Understanding the natural world is something we consider very much a part of artificial intelligence. How to do vision, how to do natural language understanding, how to do robotics. All of these involve aspects of artificial intelligence. And then finally, very important, is human-machine interaction. How do we develop AI systems that can interact with us in ways that are understandable to us, in ways that are explainable to us, in ways that make us increase our trust in these systems rather than distrust. One of the ways that we look at this is in terms of intelligent agent architecture, that we have the complete system going from input from the external worlds through perception, cognition, action, to acting in the world, and this loop continues. And then, of course, learning is there to take the results of perception and cognition and action and learn to do each of those better through things like experience, through things like observation of others doing those actions, through first principle understanding. So that's what we consider AI, all right? Very much broader than I think what a lot of people think about when they're coming in. So that's AI, but what is the bachelor's in artificial intelligence? One of the things that I think is very important to understand is that there's an extremely solid core in computer science, math, and statistics. This forms the basis of everything that students are going to learn in terms of the AI core. We'll talk about it in a minute, but there's a lot of commonality between what the students learn in the computer science major and what they learn in the BSAI major in terms of the fundamentals of math, discrete and continuous math, computer science, probability, and statistics. Around that core, there are two main areas that are fundamental to artificial intelligence, and that's representation and reasoning and machine learning. Around that core we have four major areas: decision making and robotics, machine learning again, perception and language, and human AI interaction. So those are the four key areas that students can focus in on. And then surrounding all of that is a focus on ethics and social responsibility. So how does that compare with the computer science major? There are 5 of the math and statistics courses are in common. The BSAI adds an additional statistics course, regression. There are 5 CS courses that are in common. The Bachelor of Science in AI does not require PL theory or software systems that are required for the CS majors, but there are 5. The 5 main introductory courses are the same. The CS major requires a minor in some subject. The BSAI requires instead 3 core courses in AI. Problem solving and representation, machine learning, and then 1 of computer vision or natural language understanding. Both require 6 computing electives, although 4 of the BSAI electives are focused on artificial intelligence. The general ed requirements are nearly identical, except that BSAI requires an ethics course as part of the major. Overall, the number of required courses are exactly the same between the CS major and BSAI. I'm just going to put this up. You can look at this, you can take a picture of it. These are some of the outcomes that we're anticipating that the BSAI majors will come out with. How to use AI techniques for solving real-world problems, understanding the core concepts of computer science, understanding core concepts of discrete and continuous math, and probability and statistics. And then finally, understanding the social impact of artificial intelligence and the ethical and social responsibility of AI majors and AI technologists to this program, to the world. I'm sorry. Okay, so that's in a nutshell what the program is. The process, again, is somewhat similar to what Phil mentioned. All students are entering as the School of Computer Science as undeclared majors. So you apply not to a major, but you apply to a school. You'll be applying to the School of Computer Science. The core curriculum for first-year students is pretty much the same. There is a introductory course in AI that's required of the AI majors and not required of CS or Comp Bio majors, but other than that, the core curriculum is the same. In spring, middle of spring of freshman year, you declare one of 3 majors, CS, AI, or Comp Bio. We do have a quota on the number of new majors per year. We'll accept, at this point, we're accepting up to about 35 new majors per year. Again, we have, so that would be your sophomores will start the program. So sophomores, juniors, and seniors, we anticipate a steady state of about 100 majors. This can, hopefully will evolve over time, but at this point, that's what we're talking about. So if you want to declare as a AI major, there are basically 2 criteria that will be used as, 3 criteria that will be used as a differentiating factor. One is your performance in the Intro to AI course. The second is that all people declaring for the BSAI major are required to write an essay that describes their interest and experience in AI. And the third is, depending on how many students we get declaring for the major, we may have optional in-person interviews to try and understand people's interests and experience in more depth. Although we are limiting the number of new majors per year, and there is a lot of anticipation that we will easily fill our quota of majors, the students who don't get accepted into the BSI major can still study most of the courses of the BSI major as CS majors in terms of fulfilling their electives, either their restricted electives or their unrestricted electives. In addition, we are starting to develop an AI minor and additional major capability so that students can take a minor, fulfill their CS minor as an AI minor, or even do a double major in artificial intelligence. Currently, because CS does have a double major, additional major availability, students who get accepted into the AI major can conceivably double major in computer science, but it's a fairly difficult thing to do because the number of courses that overlap there's so many courses that overlap that we need to, you're going to need to take a lot of extra courses in order to double major in AI and CS. As I said, we're in year 0. We currently have 20 majors. Most of them are sophomores who transferred from computer science into the AI major. I should say that there's a lot of interest in people from outside of SCS transferring into the AI major. This is not currently something that can be done. Phil, when he talked about the Comp Bio major, talked about being able to transfer from outside of SCS. That's not currently possible for the AI major. You have to be in SCS in order to take the AI major. Okay, why study AI? It's a very rapidly growing field. There's very high interest in industry. Before we started the major, we did a a survey of some of the major companies, and most of them said that, you know, with 30, 35 majors a year, they'd be able to hire all of them. So each company would be able to hire all of them. So we're not worried about our students getting jobs. And there's a very large number of areas where AI is active and needed. So, you know, it's not just the high-tech industry, it's not just the financial industry. There's a huge number of industries, you know, that basically fit everyone's interest. The other reason to study AI, there's an opportunity to change the world. I think that, you know, we feel both with comp bio and with artificial intelligence that these are technologies that are going to have a huge impact in the world in the future. And because of that, we want to make sure that our students understand their responsibilities in developing these technologies. So that's why to study AI. Why study it at CMU? Well, first, we're the only ones that offer an AI program, but even when others, and we know that others are following suit, even when others are following suit, why study AI at CMU? We've been doing AI for 60 years. 2 of the 4 co-founders of the field are CMU CMU professors. We focus on interdisciplinary education in artificial intelligence. And also there's as evidence of that, there's a university-wide focus on AI. It's a AI at CMU program that covers every college in the university. Groundbreaking AI research, everyone, as Phil said about the comp bio, everyone is encouraged to do research. The professors in the various AI subdisciplines are very accommodating and often eager to support students doing AI research, and this is something that's kind of just taken for granted here. And then finally, there's a strong focus on social responsibility. If you heard me say this a couple times, it's because I feel very passionate about it. And there's an organization, the K.L. Gates Endowment for Ethics and Computational Technologies, that focuses on ethics and artificial intelligence. Okay, so that was my spiel. If you have interest, you can send email to that email address, and one of the people involved in the program will get back to you. But I'm willing to take questions. I think I have another 5 minutes. Tom, yes? It's 11:30?
Yes.
Okay, so I have another 5 minutes. Take questions. Yes?
So, I like how the program works a lot with ethics. So just from curiosity's sake, do you think that like an AI that would be, that would have the same consciousness, like a self-aware AI including them, should be considered a person?
There's a lot of controversy over that. I personally don't feel like I have enough understanding of the pros and cons to weigh in on that, but that's definitely something that people are talking about. So the course, there's a course in ethics that ethics in AI that is the first year it's being taught. I'm sitting on the course just to help myself get better acquainted with this, and one of the lecturers was talking about that very issue. And again, there was nothing came, the definitive answer about that. As I said, it's a very interesting, controversial subject.
Do students have access to the cloud to run massive AI jobs or like GPUs or?
So that's an interesting question. I thank you for bringing that up because I forgot to mention it. One of the things that we are planning on doing is opening a AI makerspace within the next year that will include a lot of hardware and software that is needed for students to run experiments and do research, and that will be available open to the community. In addition, there are classes that have access to Amazon Cloud Services. And I know of at least 2 companies that want to donate AI hardware for doing, going beyond GPUs, but specific AI hardware. So it's not there right now, but by the time your child gets into the program, it'll be in place.
Do you have concentrations in machine learning versus the inference portion of AI?
We don't have specific concentrations, but there are 4 clusters, we call them, and students have to take one course from each cluster, but are welcome to fill up other of their electives with some of the additional courses in the cluster or elsewhere. So some students are planning on fulfilling their outside electives using more AI, and some of them are interested in filling their outside electives with other CS courses like operating systems or compilers or something like that to get a more rounded education in computer science as well as AI. As I said, we don't have particular concentrations at this point. The program is already pretty packed, so requiring an additional concentration, I think, is going to be too much work for students. It's a fairly intense program. It's it's very mathematical. AI is kind of interesting because there's kind of equal parts of symbolic reasoning and understanding, search, planning, inference, logic, and statistics and math. A lot of the machine learning, graphical models, Markov decision processes, game theory, things like that. So it very much spans spans from kind of the discrete math to the continuous math and statistics. Makes it a very interesting program for people to look at who have very broad view of what computation is.